Okay, so this is Chapter 15, Number 10. Hemingway Inc. is considering a $5 million research and development project. Profit projections appear promising, but Hemingway's president is concerned because the probability that the R&D project will be successful is only 0.5. Furthermore, the president knows that even if the project is successful, it will require that the company build a new production facility at a cost of $20 million in order to manufacture the product. Now, if the facility is built, uncertainty remains about the demand and thus uncertainty about the profit that will be realized. Another option is that if the R&D project is successful, the company could sell the right to the product for an estimated $25 million. Under this option, the company would not build the $20 million production facility. Now the decision tree follows. The profit projections for each outcome is shown in the end of the branches. For example, the revenue projection for the high demand outcome is $59 million. However, the cost of R&D project, the $5 million, and the cost of the production facility, $20 million, shows the profit of this outcome to be $59 million minus 5 minus 20, which is $34 million. So that's right here on the production tree, or on the tree. Now, branch probabilities are also shown for the chance events. So this is our probability tree. Now, I labeled the decision nodes versus the chance nodes. And so what we're supposed to do is analyze the decision tree to determine whether the company should undertake the R&D project. If it does, and if the R&D project is successful, what should the company do, and what is the expected value of your strategy? B, what must be the selling price for the company to consider selling the rights to the product? And C, develop a risk profile for the optimal strategy. All right, so we're going to start up here, and we need to kind of work our way back on the nodes. So we'll start here at node 4, and what we're going to do is we're going to take the probability of high demand times the profit, and add to that the probability of this medium demand times its profit, plus the probability of low demand times its profit, and that will give us what this node 4 should be. So node 4 is going to be the 0.5 times all that, and we end up with 25 as our value. So that's what this node is. So then what we see is that's kind of going to be what's out here now for this, the building facility, and the sell rights is at 20 million. And so what we need to do is we need to find the max between this one and this one. And so node 3 then is basically the max of 25 and 20. Well, that's 25, so node 3 is now 25, and the decision is to build the facility. Okay. Now we have to go back again. Again, we have another chance, so we're going to take the probability here, 0.5 times this value of 25, and then we're going to add to that this probability, 0.5 times its profit of negative 5, and when we add those together we get 10, and that's going to be the value here at 2. That's the node 2 now. And so to start R&D projects, it's going to be the value of 10, and do not start's value of 0. So when we make the decision which one is the max, well, that's going to be the 10, and so therefore that's going to be what node 1 is. And so our decision is going to be start R&D project. So our optimal strategy so far, once we've gone through all those steps, is we're going to start the R&D project. If it's successful, then we're going to build the facility, and our expected value is the $10 million. Okay, so that's part A. Now part B, what must be the selling price for the company to consider selling the rights to the product? So now what we need to do is compare and look at node 3 and see, okay, well, the payoff for sell rights would have to be $25 million or more, because that is what we're at here. Do we sell the rights or do we build the facility? And to be the better of choices to make this the best, then we're going to have to be able to sell it at greater than what this value is or equal to make it a tie. Then that's going to be that $25 million. So if it's 25 or more, it's going to basically, you're going to recover the R&D cost if you add that 5 million. So that would really be 30 or more. So if you're just determining if you want to recover the R&D cost or just to sell the rights. So kind of two different options here depending on how you want to look at the picture. And then we're going to develop a risk profile for the optimal strategy. Okay, so we're going to go back here and kind of look at how the nodes work and our optimal strategy. So the 34 million, which is the top one here, 34 million, that's going to be the 0.5 times 0.5. So just the probability times the probability. So that's going to be 0.25. 20 million is going to be 0.5 times 0.3. And so what we're doing is we're kind of going back here. So we're saying we're going to be successful. And so we're just taking that 0.5 times 0.5. Then 0.3 times 0.5, and then 0.2 times 0.5, and that's kind of working our way through. We're saying we're going to build it, we're going to be successful, and that's going to be our possible profits. Now that's the top three. Well, we also have that lower one because we also have this possibility of not being successful, and that's just the 0.5 times the negative well, that's just the 0.5 because we're not taking it times anything because there's no other probability, sorry. And so that's just 0.5. And so all those had better equal 1 if we add them together. So that's going to be 3, 4, and then 5, and plus 0.5, so that's going to be 1. And so that's what it is. So we had to I had to remember to add in that negative 5 million part because we have to combine all those probabilities to make sure they equal 1. So hopefully that makes more sense on how to do something where you have to look at the decision tree, start here, work our way back, give a value to 4, make a decision, or give a number here for 4, then go back to the next one, which is the decision, and so then use the value from 4 we found, and the value in this case over here for the cell rights at 20, whichever is max, we go and say, okay, well that's what 3 now is, and then work our way back and do the probabilities there again, and then go back and find that final decision. So it's just a process of going backwards and getting to that final number 1 node. So hopefully that helps you.